So welcome to everybody. I'm an e-learning developer here at Sauce Labs. I've been educating others about technology and writing code for over a decade, and I've launched Sauce School training with the aim to help make test automation accessible to all. This is going to be a presentation of beginning test automation. It's really designed for people who have limited to no experience with automated test code. We're going to go over things like the environment setup and the different pieces that go together to make automation code, as well as talk a little bit about how products like Sauce Labs can be used to scale up your automation code. What you're going to need to know, what we're covering today is also written down. So if you miss something, if you're not understanding something, you can follow along in the Selenium Java course. You can find the Selenium Java course at training.saucelabs.com. And if you go to the Selenium Java course, the content in module 1 is what we'll be covering tonight, and we'll send you an email with that later on. The goal is to set up your environment, so that way we're ready for part 2. So tonight what we're going to do is talk about how these pieces go together and make sure that you have a working environment on your local machine so you can begin to write test automation code. But something that I think a lot of the Sauce Lab solutions architects have learned is that often this can be the most challenging part, is really getting things set up. I recommend that you take the practice quizzes in the Selenium Java course. So if you look in module 1, there's a practice quiz at 1.03. You can take this quiz and it will tell you what the correct answers actually are after you submit your responses. There's one here and there's one here. And those practice quizzes will help you with what the goal is. So let's get started. I think one of the biggest things I struggled with that when I started here at Sauce is understanding the test environment. Like any software engineering test that you have to do, some of the biggest challenge can be, what are these pieces that we're putting together and how do they work together? So as a beginner, I took a lot of research and a lot of learning and a lot of very patient people helping me out, figuring out, okay, what are these pieces and what do they do? To start out with, you have a variety of programming languages that you can write your code in. Today, we're going to be using Java. But some of the other languages supported by Sauce Labs include Python, JavaScript, C#, and Ruby. And besides that, with every programming language, there are other tools that you can use. There are a variety of IDEs that you can use to write your code in and manage your project. The one we'll be using is IntelliJ. There are tools that you can use to build your project and help all these pieces work together. The one we'll be using today is Maven. There are even different frameworks used for communicating with the browser, interacting with what is on your web page or your application that you're testing. And for each programming language, there are actually several choices for a testing library that goes along with that programming language. Python has PyTest. JavaScript has things like Mocha and WebDriver IO. The one we'll be using today is Java and JUnit 4, but there are other options. There's also JUnit 5. There's also TestNG, which are all kind of iterations of a similar testing language. Okay, what is Selenium? I hear the word test frameworks tossed around a lot, and it really confused me at first. What is a framework? Selenium is not technically a framework. Selenium is a test automation protocol. Selenium is a tool that allows you to communicate with the browser. There were different ways of sending this protocol. A protocol is essentially a way of sending data back and forth. How do we send this data and format it in a way that we can understand? Versions of Selenium 3 and below, 3.1415 and below, use something called the JSON wire protocol. It was the way to send data before. Selenium is a robotic testing tool, and it's not an entire framework. There are other pieces that go together to make your test code work that are beyond what Selenium does, which is communicate with the browser. Selenium is used with the programming language. So when you write your Java code, you have Selenium commands in there. When you write your Python code, you have Selenium commands in there. So Selenium is a piece of the framework. Selenium 3, I think, is what we're using today. There's a new version that is being released right now called Selenium 4. It works with the JSON wire protocol, but it also uses a newer version called the W3C protocol, which allows you to do more things with the browser. It just has more features that you can use than you could with Selenium 3. Let's talk about the basic steps of a Selenium test. And Titus, I'm going to pull out your code as an example for this. To create an automated test with Selenium, and Selenium is typically used with web applications, you need to create an instance of the Selenium WebDriver. You navigate to a web page. You locate an HTML element on the web page. You perform some action. So we locate a button, we click it. Anticipate what the browser response will be. After I click the button, will a response message pop up? Then you run tests and you record the test results. For example, if you anticipate a response message to happen when you click the button, you will run a test and say, will you assert that this message showed up? And it doesn't seem super important, but it's very important. Otherwise, your test will error out. You need to quit the test and exit out. Sauce Labs is an example of something called a Selenium grid. And this is why Selenium is so powerful. Why not just go in, use dev tools, test things out? With a Selenium grid, when you write automated test code, you can actually run it in parallel in several environments at once. So for each node, you can create a new operating system environment. You can open it up in Mac or in Windows and use a virtual machine for that. Then you can test it in different browsers on each of those different machines. What Sauce Labs allows you to do is run several of these machines at once, or run several tests in several different browsers at once, or any combination of those. What Sauce Labs provides is the ability you don't have to set all of this up on your own. You connect to Sauce Labs, you tell Sauce Labs which environment you want to run it in, and virtual machines or real devices are allocated to you, and you can run your tests all at once on a PC, on a Mac, even on a mobile device, a cell phone, making your test suites run much, much quicker. The WebDriver protocol used by Selenium consists of rules for communication between the client on the local end, which is you, your test code, using languages like Java, Ruby, or JavaScript, and a web browser. The Selenium language bindings bind the Java code you write to actions with the WebDriver. So the actions that are happening on your probably Selenium grid. You'll see the driver keyword a lot to interact with Selenium. And we'll be using JUnit 4, which is a library or package that allows you to communicate with Selenium and run unit tests. So real quick, I want to show a couple examples of what this looks like. So here's a very, very simple example of a test that you might run. It's basic. The first thing you do is you set things up and you instantiate a driver. You navigate to a web app. You go to saucedemo.com. You'll see that this is a web app. You can log in, put in a password, there's a button. Next, you synchronize with the element that you want to use. So we use the locator, and it has a class name. If you look at the web app that is under test, the application that is under test, and you inspect it, you'll see that the class right here, button action, corresponds with what we have in our code. We have a timeout here just to give it a little bit to allow things to load. You locate the element, you click on it, you assert that the title says Swag Labs, and you quit. So those are the basic elements of a test. The power in this is not that we're doing it with a robot, but the fact that you can do it with a robot on many, many machines at once. So you can test all the possible combinations that your users might use their application in. A little bit about the driver method. You saw in the code, we instantiate a driver. You instantiate a WebDriver, and when you instantiate a WebDriver, you have access to the methods, things like get element by, click. Selenium uses the driver to automate and manipulate elements in the browser. Some examples of drivers include Chrome driver for Chrome, and there's Gecko driver for Firefox. If you're setting up an environment on your local machine, you need to actually install Chrome driver in a version that matches with the version of Chrome you're testing against. If you are using Firefox, you need to download Gecko driver version of it that is compatible with the web browser that you're testing against. And in your code, you need to set a path to it. When you test on Sauce Labs, all of that's sort of taken care of for you on the back end. JUnit 4 is an important part of this. All of these things together make up sort of a framework. JUnit 4 helps do things like orchestrate what order things happen in the test. Without this, you can have several things happening at once, things can get interrupted, and you usually need to use something that allows you to, it's called orchestrate test execution. So if you want to run it in parallel and run several tests at once, you usually need to use with JUnit 4, you need to use something additional for that called the Surefire plugin. So here's an example of, in your test, which elements are part of Selenium. You have your imports list, and you import the different libraries that are used, the Selenium BY library, the WebDriver, Chrome driver, and Chrome options, which give you a certain functionality. You instantiate a driver, which is also the Selenium element of this. You create a driver for your test. And all of these commands right here within this test method are also the elements that are Selenium, as well as the driver quitting in this test. You can see other things in here, such as JUnit commands, and obviously all of this is written in Java, but these are the elements that make up Selenium. Something else we'll learn about a little bit later on is something called the pom.xml file, which is used by Maven to help bring all the pieces together that you need to write your test. In the pom.xml, you actually go and grab these dependencies in the version that you want. And because Maven does that for you, it's easy to import it into your test. It'll help do things automatically for you, so you don't have to go in and figure out what all the pieces are yourself and hard code that in. The next thing we're going to talk about are test frameworks and dependencies. So your TestRunner, in this case, it's JUnit. TestRunner is a library or tool that takes the tests you write, along with settings you've configured for your tests, and executes them. We'll take a look at that. And then actually, let's go back and take a look at this. As an example here, you can see the at before, at test, and at after annotation. Those are specific to JUnit 4. And that tells you before every single test is run, you pass the information into here and you set it up. And at the end of every single test that is run, you run this method, which is the driver quit method. We'll be using JUnit 4. There are options, JUnit 5 and TestNG that different people prefer for different reasons. JUnit 4 has been around the longest, and data shows that it's the most used. It doesn't always mean that it's the best, so I'm going to leave that up to you. So here are some JUnit 4 elements. We're importing these classes, and here we're using these test annotations, which are very important for the order that you execute things in. If you switch to JUnit 5, I was talking with Titus about this earlier, the way you write these are very different, and it can change from test to test. Again, we have this managed by our pom.xml file, which is the file that Maven uses. So what is a framework? It is not just Selenium. It consists of what Marcus Merrill likes to call a robot, the one that interacts with your, in this case, it'll be a web application. So Selenium, it's how you communicate with it and give it commands. TestRunner, it orchestrates how your test gets put together. And reporting, some test runners include reporting. I believe with JUnit 4, you need to use something called Surefire plugin. A framework is not just one tool. This is something that really confused me for all. Framework is a collection of tools that do all of these things. And because of the way it's structured, it provides sort of best practices for code structure. We'll talk a little bit about page object model later on. It helps you handle the data from your test code, also helps you report. It can also help you create reports on that. And then tools and guidelines for creating suites, your test suite. So a framework is a complex set of things that work together. This is a simplified diagram sort of how it all works together. So you have your test framework, you write it with Java, JUnit, and Selenium. Those commands go in there. It then gets sent to the Selenium server. You can run one on your machine. It can also send it directly to the browser or the grid. Communicates with the WebDriver, so Chrome driver for Chrome, Gecko driver for Firefox, and there are other drivers for Safari and Internet Explorer. And then it makes a round trip. So you send your commands, goes to the Selenium server grid, goes to the WebDriver, goes to the browser, and for each command, it actually has to make a round trip all the way back. So go here, here, here. Here's something also I've found that is this is one of the harder things about setting up your environment. In order to write test code, you need to install the Java development kit. There is a difference between the Java runtime environment, which anyone can download and use to execute Java programs, and the Java development kit. The Java development kit includes the Java runtime environment, but it also has other tools, tools that are necessary for you to write the Java code and to execute the tests. It's important to make sure that as a developer, you install the JDK and not just the JRE. Maven is our build automation tools. I like to think of it as putting the pieces together. It manages other required dependencies like your version of Selenium and JUnit 4. It helps you build any application code you create. So with Java, we have to compile it and then run it. It helps organize and perform the tasks needed to build and execute your test suite. As I mentioned before, the pom.xml file tells Maven which dependencies to use for your environment and to set up your project. The IntelliJ IDE is what we'll be using in these examples. The documentation that we have shows you how to use this tool specifically. It is free. You should be able to install it on a PC or on a Mac, and I imagine on a Linux machine. So if you go to jetbrains.com, IDEA, download. It's your code editor and sort of project tool that you'll use. And all of this will be written down, so don't worry about doing it all right now. It provides an interface where you can interact with other tools, such as Maven. So you'll see a little tab right here. If you have everything installed correctly, you can use Maven. You can give commands to it. You can also, if you're using version control, you can use Git. It makes it really easy to jump to any commit that you would like, jump to any commit that is either on your local or remote machine. And a couple other things I want to point out. On the left side here, you should be able to see your project structure of the code. And right here, we're looking at the pom.xml file, where you can see all the dependencies that you're using. It also has really, really handy dandy tools to run, test, and debug your code. So you can run individual test cases, see what's happening, step through it, and do a lot more, which we'll go over a little bit as well. I'm going to go back to this. So if you go to training.saucelabs.com and you go to module 1, if I move too fast for you, everything that we learned about is in 1.01, 1.02, 1.03, and 1.03 has that little practice quiz for you, and 1.04. So it's just a written version of this. An important thing with Java is that you need to make sure you have environment variables set up. So you need to tell your machine, whether it's a PC or a Mac, if you have a Java program, what program are we going to use to run this? And this is something that can be a bit of a struggle. I have trouble with it on Windows, but hopefully we'll be able to work through that together. You'll need to install Maven and use that with IntelliJ. You can also use IntelliJ, I believe, to get to download and install Maven. JUnit 4 is something we're using. Maven will actually take care of installing any of those dependencies, but know that we'll be using it and that it's an important thing to understand if you're trying to debug your code. What am I using? What programming am I using? What test runner am I using? And again, the IntelliJ IDE. It is not strictly required to use that if you understand how to build your code and run it. But because test code is structured and executed differently than traditional Java code, it's easy to use the IntelliJ IDE to run tests. I recommend that you install Java first on your machine, just to make sure. And there might be issues with installing Maven if you don't install Java first. The instructions in 1.05 here are for Mac. If you are using Windows, click on this link, and this is a guide. Okay, let's see. I'm going to look through some of these. Yes. Yeah, so Maven doesn't create the pom.xml. You create the pom.xml, and it tells Maven what to do. And in here, you will see the actual code for when you have a pom.xml, what you fill in. And all you need to do is copy paste it, and we'll set it up as you need. So let's go through this real quick. You can check to see if you have Java set up on your machine. If you have a Mac, the easiest way to do that, see if you have a Java home variable set up. As you can see, I have JDK version 14 on here. You can also choose within IntelliJ which version of it to use. If you want to check on your Windows machine, if you have it, you can open the command prompt and you can check your system environment variables. I know there's a command to do it too. I forgot what it was off the top of my head. Let's see, what else is important? Download the JDK. 8 is the most commonly used one. It will work just fine for our purposes. So this will be the first thing you need to do. Install Maven, although I believe you can do that with IntelliJ. But if you have a Mac, simply running this command, I don't know why there's a period there, that's a typo, should work. You need to update your bash profile to say, hey, we have Java installed. This is where it is. This is the way to it. If you type this into your bash profile, that would work. If you're like me and you have a version of Mac Catalina or later, you need to update your .zshrc or create one. The bash profile is the profile that helps tell programs on your computer, what program do I use to run this? Instead of bash profile, newer versions of Mac use ZSHRC. Other than that, we install IntelliJ. You'll walk through this workflow to get Maven working on your machine. Create a project file. If you set up Maven as your build tool, it should automatically create a pom.xml file in your program. And all you need to do is copy paste all of this and restart IntelliJ. I'm not sure if this is something I include in here, but once you have your pom.xml going, it's a good idea to go to File, Invalidate Caches, and Restart, because then it'll take everything into consideration. And then this kind of goes over installing IntelliJ dependencies. So just to be clear, the ones that are published on this page in 1.05 are for Mac users, and the ones linked right here are for Windows users. So if you're a Mac user, you can just follow what's on here. If you have a new version of Mac OS on here, Catalina or later, I think Catalina 15 or later, you need to look in your bash profile. The way that you would find what you have is I'm in my main user menu. You hit ls-la. You can see all the files that are on here. The little period here means that it's a hidden file. So you can't see it if you do the command ls, which lists everything that you have. If you're on a Catalina 10 or later, you might actually have to create this ZSHRC file. And you would do that by saying touch ZSHRC, and that'll create that file. Then you can open it and edit it.